can shift left by 1. So that would be y equals to minus the square root of x plus 1. And then what? Go up 2, right? So that we get minus the square root of x plus 1 plus 2. And we could make like an animation, right? We could draw a series of graphs to illustrate how we're getting to the final result, like step by step. So, start with the square root of x. Then what happens? We go to minus the square root of x, which is down here, right? Then we shift left by 1. And then finally we do what? We go up by 2. So my square root shape is degrading as I go down the board, but I hope you get the idea. So, I mean, if somebody says, here's a function, what's the equation of it? That's pretty challenging, isn't it? Even if you have a few points on it. If they tell you it's part of a parabola tilted sideways, right? Then you kind of know you could build it from using the square root function shifted around and stuff. But anyway, you know what? There are very good problems in the book to try to help you make sure you have these ideas down. And I think, for example, problem 71 and 73, these are really good because there's not a formula. There's just a graph. I cannot reproduce those on the board worth anything. I'm not even going to try, but those are really good problems to try to work through. I think the examples in the homework here, which have pictures in them, are especially useful in this section because those are, often test questions. Now, the one last thing I should talk a little bit more about in the time that remains. We still got 5 minutes, right? So let's circle back and talk more about piecewise defined functions. How's that work? This will not be the last day I talk about piecewise defined functions, but I should try to continue talking about piecewise defined functions until we get it, the idea. So here's an example. F of x equal to x squared if x is greater than or equal to 0, and minus x squared if x is less than 0. So this is a piecewise defined function because I have a different rule on different parts, right? So in other words, if you think about it graphically, it's y equals x squared for x greater than or equal to 0, right? And it's y equals to minus x squared for x less than or equal to 0, less than 0. So if you were to graph this thing, it's kind of neat, right? It looks like a parabola that way, and it looks like a parabola this way. So so you might think it's a cubic if you don't. I mean, to the limits of my artistry, my graph of this function and my graph of a cubic function look pretty much the same, right? But they are different functions. For example, just to be clear, if g of x was x cubed, right? There's the cube function. Tell me what f of, let's calculate, what is f of 2 versus g of 2? Oh, g of 2 is what? Yeah. 2 cubed, which is 8, right? What's f of 2? There's another piecewise defined function. F of 2 here is given by 2 squared because is this a positive input? I mean, yeah, so it fits into case 1. So if I was to draw the cube on here too, the cube is like, it's more steep. I haven't done that justice though. They agree. Good grief, I have not. That my picture's wrong. The graph is. This picture's fine. It's just I can't draw the cube and the. Remember that thing we talked about the other day? They cross over at 1. I got to worry about that, you know. I think this is the right way. No. Let me stop trying to draw those. This is another example. Just you answer 2 questions. 2 questions more will be done for today. What is f of 2? What is f of 0? How does this work, right? We have to figure out which case we're in before we do the evaluation. So like 2 fits into this case. So I use this formula. So f of 2 is 2 squared. 2 squared is 4. But yes, heart in the right place. But let's see here, f of 0. 0 fits into case 1, right? When we plug in 0 into this, what do we get? 8, right? So if you were to graph this thing, it's like it's got a y-intercept of 8, it's got a slope of 2, something like that. And so it gets all the way over to 10 here, and then it drops back to 1, and then it's a parabola going upward, something like that. So the graphs of piecewise defined functions, they can be, pretty funny looking. So I'll try to include more examples of piecewise defined functions as we go on here. All right? Anyway, have a good weekend, you guys. I'll see you Tuesday. You can expect an announcement about what I talked about earlier. So if I don't send that announcement for some reason,